Hi, welcome to Shuko Math Lab differential equation problem solving session. So here is the problem we're going to solve today. It's xy prime plus y equal to y squared ln x. The initial value is y to the e equal to 1/3. Okay, so here is our problems here. So let me first add a page here. All right. Okay, so here is my problems here. By first, remember, we talk about every time when we try to solve the differential equation, the first thing is let's take a look at this equation and investigate what type of the method we can use. Okay, so for this one, I thought the first things you see, this is y prime, y, and y square. Well, it's nice. It's kind of linear, right? And also then the next things I observe is like the value next to it is just a simple function of the independent variable x. So I think this will be a pretty good candidate for using the Bernoulli equation methodologies here. All right, so that's what we're going to go ahead and start to that approach. So let's rewrite this one a little bit. Like I always like to put the y prime like dy dx plus y and the y square ln x. Okay, so the first things I want to change to the Bernoulli equation. Like always, I will write down the Bernoulli equations here. This is dy over dx plus the pxy equal to the qx y to the n. Okay, so let's go ahead and do that. And so first things here, I'm going to divide by x on the both sides. Okay, so I can change it to the Bernoulli equation form. So I will have a dy dx plus 1 over xy and equal to ln x over x y squared. So from the Bernoulli equation, so I know this one's here, this is my n's here, right? And this is my px. Okay, so now after we know that, we can just follow our typical step here. So the first step is to define a new variable v. So I will say that v is y 1 minus n. So it's 1 minus 2. So I will have here. So I will have y equal to the negative 1 is 1 over y. All right, then I'm going to take the derivative. So the derivative both sides. So dv dx is equal to, right? So that this is y to the negative. So it's negative y to the second and the dy dx here. Okay, so I need to be careful right here. This is a dy dx. Okay, so let's write a little bit better. So this is a y squared negative 1 dy dx. Okay, so the step number 2 is I'm going to replace my initial equation dy dx with dv dx here. All right, so now the dy dx, so here, okay, so that means I need to times the y squared both sides here, right? So here, okay, so I should have finished this step here. I need to change the, okay, so times negative y squared. So this is negative y squared dv dx equal to dy dx. Okay, so I just changed my dy dx to be a function of dv dx. Okay, so the step number 2, I need to replace my original. Okay, so this is my original Bernoulli equations, right? So I need to replace the dy dx with a new variable. So this will give me negative y squared dv dx plus 1 over x y equal to ln x y squared. Okay, so after that, we need to simplify a little bit. So I want to simplify to the Bernoulli equation format. So what I need to do, this is negative y squared, right? So what I need to do is I need to divide by, so that means I need to divide by y squared. Okay, so sorry here, here. Okay, so this is ln. I did need to be careful. Okay, so my right hand side to the original equation is my right hand side to the original equations here is ln x. I need to be very careful. X y squared. Okay, so I want to get a dv dx, so I need to divide it by negative y squared, negative y squared. Okay, so now my left-hand side, y squared cancel, so I will have a dv dx. Then 1 over x and y over y squared. So I have negative 1 over x times 1 over y. That's right, because y and y squared cancel. Then these ones here, they cancel. So I have negative ln x over x here. Now, one last step, v is equal to the 1 over y. So now I change here, I say dv dx minus x to the v is equal to negative natural log x over x. All right, so this is the step number 2. And then after that, we change it to this simple ordinary differential equation. And the number 3 is here, the linear equations here. Now, the number 3 step is probably the most important step, is I want to find the integration factors here, right? So this is my new, so remember that this is my new px, right? So it's negative. Okay, so now let's do this. So here I said a du dx will be equal to negative 1 over x times u. Okay, so times u, and now I need to solving for u. Okay, so the solving for u, I can just do a separation. So I will do du over u is equal to the dx over x, the negative signs here. Then I integrate both sides. I will get the ln u equal to the negative ln x. Then this negative sign you can put in the front will be an ln x to the negative 1. So it's equal to ln 1 over x, right? Okay, so that's why I can get my integration factor u is equal to 1 over x. All right, so now this will be, okay, so let's highlight. Okay, so this is my dv dx, all right? So this is my integration factor. So what is the next step? Next step is we need to multiply this integration factor back to my equation here, right? This purple one. So I will have 1 over x dv dx minus v, the x squared, is equal to negative ln x to the x squared. So I multiply the 1 over x both sides. And then, like always, so here we'll recognize what is this one's here? All right, so we recognize this one is the derivative of a product function. So what is this product function? Here is 1 over x times v. Okay, so this 1 over x times v is equal to negative ln x squared. So now, okay, we can do is let's integrate both sides. Integrate both sides here. So we will get a step number 4. Integrate both sides. So the left-hand side, you integrate a derivative. So it's just be 1 over x times v. Then here, this is a negative ln x and x squared dx. All right, so how do we integrate? So now, let's take a look. How am I going to integrate these numbers here? Then we will put a negative sign in front of it. Okay, so now let's go ahead. So for this ones here, this is ln x squared dx. So for this one, we can use integrate by part. So we can say integrate by parts. Okay, so I will let the u is equal to the ln x. So the du is going to be 1 over x dx. All right, so here. And then I will let the, okay, so then I will let the v dv is here. So the remaining 1 over x squared dx. Oops. Why did it jump over to here? Okay, so this will be, okay. Okay, so by parts, then I will have 1 over x squared dx equal to dv. So then I have v is equal to the negative 2 plus 1, so it's negative 1 over x. Okay, so now by parts, so this integration will be equal to the uv, so it's a negative ln x over x minus v du. Okay, minus minus, so it's a plus v du. So it's plus 1 over x squared dx. So this will give you negative ln x over x here. And 1 over x squared will be, you integrate will be negative 1 and 1 over x. All right, so this is what is my integrated by part for the natural log x over x. Now in here, I can put back to here. So this will be this negative sign still in the front, right? So the negative, so it will become ln x over x plus 1 over x plus c. Okay, so now in here, we got this one. So 1 over x. And the v is from the previous, we know what is my v here. Hey, v is 1 over y, right? So v is 1 over y. V is 1 over y is equal to the ln x. Okay, so it's ln x over the x plus 1 over x plus c. So I can find 1 over y times the x both sides. I will have ln x plus 1 plus cx. Okay, so now ye, my initial conditions here, ye is equal to 1/3. So when x equal to e, y equal to 1/3. Okay, so this is 1, this is 1/3. So LE plus 1 plus CE. So I will have this is 3 LE, this is 1, right? So this is turn out to be 1. Okay, so 1 plus 1, so 1 plus 1 plus CE. So that's why I have 1 equal to CE. So that's why I have my C equal to the 1 over E. So finally, I got my answers here, right? So this one will give me 1 over Y is equal to the ln x plus 1 plus x over e is here. Now you can flip it. So that's why y is equal to ln x plus 1 plus x over 1. All right, so this one is not bad, not too bad. Okay, so it's pretty easy as soon as you recognize this equation match the Bernoulli equation, then you will be able to follow the step. All right, that's it. I hope this help you with this homework, and let's talk about some other problem next time. Okay, have a good day. Talk to you next time. Bye.